Hello everyone, this is Akansh Suman here. Now we will do questions based on the epicyclic gear train. We all know epicyclic gear train means apart from the rotation of the gear, if any axis of the gear is in rotation with respect to some other axis of the gear, that would be known as the epicyclic gear train. It may be simple epicyclic, it may be compound epicyclic, it may be reverted epicyclic. So that is the questions of the epicyclic gear train, simple epicyclic gear train. Okay. In the question it is given that a 2 degrees of freedom epicyclic gear train is shown in figure. If you want to know the degree of freedom, you can just calculate here. We all know the degree of freedom formula, F is equal to 3 into basically epicyclic gear train having 2 degree of freedom. Okay. So we can see here how it is calculated. It is calculated 3L minus 1 minus 2J minus H. Okay. First we need to calculate the number of link. You can see here there is a fixed link. We all know that it is a fixed link on which gear A is in rotation. Okay. So that is one fixed link, that is another, and that is 3, and that is 4. So basically there are 4 number of links. And how many binary joints are there? How many joints are there? See, this is one fixed joint, that is one. Okay, one joint here on which A is in rotation. There is another joint by which this arm is connected with A. So how many joints are there? That is one with A, and that is another, that is with arm, and that is another, that is 3 joints are there. So I'm just writing here 3 joints. Okay, are you getting my point? Yes or no? This is the arm which is connected to A with another joint. Okay, fixed joint is that means the A is having the fixed joint, that is having the rotation, okay, about a fixed joint, and the another joint between arm and the gear A. Okay, so that's why here 2 joints are there, and that is another 3 joints. And how higher pair are there? That is one higher pair, because there is one point of contact between these 2 links. That is here, you can see here one point of contact. So just put the values in this equation, you will get the final answer. 3L minus 1 minus 2 multiply 3 minus 1. So here you can see that is a 9 minus 6 minus 1, that is 2 degree of freedom. Okay, so whatever be the given in the question, 2 degree of freedom, it is right. Okay, degree of freedom for the epicyclic gear train is 2. Okay, now we have to solve the questions. Right now it is given in the question that rotational speed of the planet gear B, we have to find out. Now see the structure and understand this gear train. A is having the fixed link here about which it is in rotation, but B is in rotation with respect to A. Okay, and that's why it is connecting with the arm or a carrier. Now how we solve the epicyclic gear train problem? So I'm just showing you. You have to draw the block. One block with arm is having 0 speed. Okay, so here you can see that is in the first block I am considering motion, in the second block I am considering arm, in the third block I am considering A, and this is B. Okay, just have to draw the blocks. In the motion block I am assuming that now you just need to understand. First I am going to fix the arm, there is no motions in the arm. Okay, so I'm writing here that arm is fixed. Arm is fixed here. Arm is fixed. When the arm is fixed, that means the rotation of the, that means the speed of the arm is 0. Okay, and when I fix the arm, I'm assuming that let the gear A, let the gear A is having x rpm. That means it rotate with the x rpm. Let gear A rotates by x rpm. Okay, x rpm plus x rpm I'm considering, and plus sign I'm considering from for clockwise direction. So I'm just writing here plus means clockwise. This is my assumptions. Okay, and minus sign I'm assuming that anti-clockwise direction. So I'm assuming that the gear A rotate with plus x rpm. Plus x means clockwise. Okay, since arm is fixed, then the here we have to write down the speed. Okay, so that is arm is having 0 speed. Okay, and I'm assuming that the plus x, and that is plus x rpm, which is in clockwise direction, and we have to write down the speed for the B. See here, arm is fixed, it is having a 0 velocity, and the x is in clockwise direction with the x rpm. What would be the speed for the gear B? That would be in anti-clockwise direction. Okay, that is minus x, and you have to write down it like that, minus x, that is the teeth TA on the gear and teeth TB on the gear B. You have to write down the speed for the gear B, minus x multiply TA upon TB. You have to write down the speed for every gear like that. Okay, the teeth on that gear and teeth on this gear. Okay, that is the speed of the gear. This is the speed of the gear B. You can write it as it is. We will do some questions so that you will be able to understand more precisely. So that is minus x TA upon TB. Now I am saying that the arm is free. Now if arm is free to rotate, then it would having the, I am assuming the speed of the arm is y. Okay, and here it would be x plus y. Y means plus y means in clockwise direction. Okay, so it would be y minus x TA upon TB. You have to make a table for epicyclic gear train like that. Whatever be the number of questions we are going to solve, we have to draw the table in a similar way. Okay, first we have to assume the arm is fixed, and as we have assumed the arm is fixed, we have to write down the speed of the gear A and the gear B. Okay, like that we have assumed, as well as x rpm clockwise direction, and on the basis of that, arm is having 0 velocity and the gear is having the x velocity, and we have to write down the speed of the gear B on the basis of that data, that is minus x TA upon TB. And we just have to assume the next case. Our solution is based on that equations. Because the arm is having the rotation. In the question it is given that arm is having the rotation, so our calculation is basis on that data, these data. Okay, so next we have assuming that arm is free. Okay, that is having the x rpm, and we have to add the arm rotation with the every gear like that. Now see here, what is given? Arm is rotating with the 30 rpm in the anti-clockwise direction is given. Because it is anti-clockwise direction, and we have assumed minus sign as anti-clockwise. So I am writing here what is given, that arm is having, arm means speed of the arm y is having 30 rpm, but in anti-clockwise direction, that is minus 30. Yes or no? And gear B, gear A is in rotation. That means the speed of the gear A, I am writing here speed of the gear A. Speed of the gear is what? X plus y. X plus y is equal to, this is also anti-clockwise direction, that is minus 120. Okay, and speed of the B, we have to find out the speed of the B, and speed of the B means what? Y minus x TA upon TB. What is TA and what is TB? Teeth on the gear A and teeth on the gear B, that is 80 upon 40. So 80 upon 40, and that is equal to what? We have to find out it. Okay, we have to find out NB. NB is not given, we have to find out. How can we calculate NBC here? Y is given, that is minus 30. From this value of y we can calculate the value of x. Okay, so x minus 30, that is equal to minus 120, and here we can calculate x is equal to minus 90. Okay, when you calculate this, we'll get the value of x, that is minus 90. This is not the speed of the a. Speed of the a is this, x plus y is the speed of the a. Okay, so this is just the value of x, that is minus 90, means 90 rpm in anti-clockwise direction. Okay, so we have to put the value with the sign, that is the minus 30 and minus 90 multiply 2. Okay, so here you can see minus 30, and here it would be plus 180. Okay, and you will get the 150. This is with the plus sign, that means speed of the B gear, speed of the gear B, that is plus 150 rpm. That means you can write is 150 clockwise, 150 clockwise. That would be your answer. Okay, so 150 clockwise would be the answer. I hope you will understand the solution of that question. We will do the same procedure in order to find out the speed of the gear, and if they ask the teeth on the gear, we will do the same procedure. First we have to draw the table. Okay, so thank you.